In-situ resource utilization is the holy grail of the space industry. There is no more costly supply chain than the tens of thousands of dollars that's required to launch even a single kilogram of material into space. Privatization of the space industry has helped to lower that cost, but in order to create a step change in our ability to explore and colonize space beyond near-Earth orbit, we have to learn to build and create materials from the raw matter we find on lunar, planetary, and asteroid systems. I'm Chris Taylor, an engineering physics PhD, and I'm the founder of MCE Nexus. MCE stands for Materials, Chemicals, and Energy, and our team of chemists, physicists, and engineers understands that in order to sustainably manufacture resources in space, we need to build space-based industrial parks that co-create materials, chemicals, and energy symbiotically. Consider the kinds of materials that will be needed to sustain a colony on the Moon or Mars. In addition to providing food, water, and oxygen for life support, the infrastructure itself will have needs to grow over time and be replenished, repaired, and maintained. For transportation, vehicles will be needed, requiring high energy density fuels. Systems will need to be sealed and moving parts lubricated, requiring polymers and greases. Metallic parts will need to be repaired or replaced. Technologies like 3D printing or metamorphic manufacturing will enable net-shape part production, but the problem of obtaining the raw materials has yet to be solved. At MCE Nexus, we started out by taking a top-down view of those needs, and we realized that the systems that will create oxygen and water for life support, as well as hydrogen and methane for fuels, should best operate within an industrial park-like environment. To efficiently exchange byproducts and waste streams, we designed a flow sheet for cogeneration of materials, fuels, and precious metals from the ores expected to be found on the Moon and Mars, based on our current geological maps. One of the central technologies we are focusing on is an electrolyzer, in which minerals are dissolved within a molten salt bath and the electrochemistry tuned to extract materials of interest, such as molecular oxygen and chlorine at the anodes and hydrogen, iron, aluminum, or silicon at the cathodes. Based on our flow sheets, we estimate that a megawatt-sized power source could be used to generate tonnage quantities of these materials per day, which is effectively millions of dollars saved on a daily basis, just by cutting out the supply chain. From the Earth side, those innovations will also be attractive because they will by necessity be zero carbon and non-water intensive. There are no coal seams or oil and gas reservoirs in space, no fresh running water, so the industrial symbioses we are working on for the space economy will help with the zero carbon energy transition here on Earth. Just consider how carbon intensive the steelmaking industry is, for example. MCE Nexus is an early stage startup looking to get connected to partners in the space industry to better understand current and medium-term needs and opportunities where we can participate. Our mission is to utilize our expertise in chemistry, physics, and engineering to build a circular economy for the co-production of materials, chemicals, and energy in space.